A supernova is when an enormous supergiant star explodes at the end of its lifetime. The star must be at least 8 times the mass, but no more than 50 times the mass of our Sun in order for the explosion to happen. Through observation and testing in the 1930s, Fritz Zwicky, a Swiss astronomer, and Walter Bade, a German astronomer, created theories of supernovae in the 1930s. A few years before that, in the late 1920s, Zwicky became fascinated with cosmic rays and their origin. He suggested that they were caused by huge explosions of massive stars. It was then that Walter and Fritz teamed up to study the phenomenon. They discovered that after such a violent collapse and explosion of a star, there must be a mass of neutrons left behind, which is now called a neutron star. At first, Zwicky called this occurrence bright novae, but then the name supernovae was later adopted. There are many types of supernovae, but in this video we will focus on type 2 specifically because of the interesting fact that they can turn into black holes after explosion. All stars generate nuclear fusion. This is where there is a nuclear reaction from the collision of 2 or more atoms, which creates a new nucleus. In all stars, it is hydrogen atoms colliding into other hydrogen atoms. This creates helium atoms, which releases energy from the star. This energy created from helium keeps the star from collapsing from gravity. When the star runs out of hydrogen, it is overcome by gravity, which causes it to collapse. After boiling a small amount of water inside the can, we flip it upside down very quickly and place it into a bowl of ice-cold water. The quick change in temperature vaporizes the water inside the can, causing it to collapse immediately, similar to a supernova. When the star collapses due to lack of hydrogen, it releases an enormous amount of energy which causes it to explode. This demonstration is meant to show the explosion of a supernova. You can see these 2 objects collapse into one another and then release energy, causing them to bounce away from each other, which demonstrates the process of the explosion after the collapse of a supernova. After the explosion, there are several possibilities as to what will happen to the remnants of the star. Sometimes there is a ball of neutrons left behind called the neutron star. Specific to type 2 supernovae, if the mass of this neutron star is too large, it will continue to collapse, fold into itself, and create a black hole. Finally, during all supernovae explosions, debris from the supernovae is scattered into space, which sometimes turns into other stars.